Dear students, I welcome you to my video lectures. I'm your course instructor, Dr. Mazullah Khan, and today I will talk about chapter number 13, which is capital budgeting techniques. There are 4 different methods for project evaluations. We covered payback period and internal rate of return, and today I will talk about net present value and profitability index. And the reason I will cover both these topics in one lecture because the methods used in these two techniques are very close to each other. So I'll give you a quick recap of internal rate of return. Internal rate of return is very easy to calculate in some softwares, of course, Microsoft Excel and some other tools. But let's say if you would like to manually calculate it through trial and error method, you use interpolation for that. Once we calculate the IRR, we compare it with the hurdle rate. It is also called the cutoff rate. If the IRR is greater than or equal to the hurdle rate, we accept the project. If it is less than the hurdle rate, we reject the project. So the acceptance criteria is plain and simple. If the IRR, as I said, is more than cutoff rate, we accept it. If it is less than the hurdle rate, we reject it. Net present value. So in this technique, we will be heavily using the time value concepts that we learned in chapter number 3. So net present value is the present value, of course, of an investment project's net cash flows minus the project initial cash outflow. And the way we calculate it, of course, each cash flow we have to discount it with a certain rate. So in IRR method, my task was to calculate this K. In NPV, net present value, K is given, and then I have to calculate NPV, which is the net present value. So we will be working with the same example. Julie Miller, she is evaluating a new project for Basket Wonders. This is the timeline of the investment. So timeline of the project life cycle. So at time 0, she is investing $40,000, and then in year 1, she is getting $10,000, in year 2, $12,000, and then $15,000, $10,000, and $7,000 in year 3, 4, and 5. So my first task is actually to discount all cash flows. And then finally, I will discount the $7,000 as well. And the rate that we will be using is actually, that rate is given. So management already knows that based on the riskiness of this project, they will expect a certain rate of return. And that rate of return is called actually the required rate of return, because this is what the management requires. So in numbers form, this is exactly the same thing that we did on the last slide. So the first cash flow, you have to, of course, discount it for 1 year. And then the cash flow for the second year, we have to discount it for 2 years. And similarly, other cash flows. NPV, of course, we have to take out the initial cash outflow. And that's why it's called net present value, because we are subtracting the initial cash outflow from the present values of all inflows. We can use the table which is given at the end of the book. And of course, once you plug in all those present value interest factors for 13%, 13% is actually the required rate of return, which is in this case K. So once I calculate the present value of all cash inflows, it is 38,572. And of course, she is planning actually to invest $40,000 in the project. So the net present value is minus 1,428, which is less than 0. It's negative. So the acceptance criteria is plain and simple. If the NPV is negative, we reject that project. So in case of basket wonders, for a required rate of return of 13%, the project is actually rejected because the NPV is negative. And of course, if we change here the required rate of return, it will change the NPV as a result. So the required rate of return depends on the riskiness of the project. If a project is less risky, the management may be able to accept projects, comparatively a lesser required rate of return. For example, 12% or 11%. It really depends on how risky a certain project is. Strengths and weaknesses of NPV. So in IRR, as I said, the cash flows are given, and then we have to find out the internal rate of return. Here, the internal rate of return is given. So the strength is that all the cash flows are assumed to be reinvested at a hurdle rate. The second strength is the time value of money. Of course, we take into account in NPV. And the other major benefit is that we take into account all the cash flows. One of the major weaknesses of this project, net present value, is that it may not include the managerial options. Now, managerial option is a very, very technical term. And I'll give you an example. So suppose, let's say, if a company, let's say it's a software company, if they would like to invest in Pakistan, sometimes the project itself, the net present value for a certain project, let's say, is less than 0. So only on this simple criteria, you may reject this project. But NPV does not take into account what they call managerial options. And one of the most important options is actually their ability to operate in Pakistan. So for example, let's say if there is any licensing required in the whole process, once they get a license to operate in Pakistan, in future they can expand geographically. So although a certain project may be rejected based on NPV because the net present value is less than 0, but once you get a license as a result of that project, of course, it helps you to expand in future. Unfortunately, NPV, although it's a very, very strong technique, it overlooks or it doesn't take into account the managerial options of the company. Now, net present value, as I said, this K is given, and then we calculate the net present value. So if I plot all the numbers for different discount rates, we get this line. Anything less than the hurdle rate, of course, it results in a negative NPV, and those projects are rejected. IRR, by definition, it's that discount rate at which the net present value, which is actually the y-axis, it's 0. So the rate at which the net present value of a project is 0, that rate is called IRR. But let's say if a certain company, because a project is not that risky, if they are willing to accept a project for a lower discount. For example, let's say 7.5, right? So this is the net present value that the company is hoping. So whenever we adjust the discount rate, the net present value reacts to that adjustment accordingly. So if the discount rate is high, it means the project is more risky. It may result in negative NPV. And let's say if the project is less risky and the required rate of return is, or for that matter, the discount rate is less, then of course it results in a higher net present value. So whenever I'm moving in this direction, which means that the discount rate is becoming less and less, the NPV as a result keeps on increasing. So this is kind of a sensitivity analysis of the net present value, and it's called the net present value profile. Profitability index. So if you remember, for NPV, what we did, we subtracted the initial cash investment. But here in profitability index, what we are doing, we are actually dividing the net present value of cash, of all cash inflows by initial cash outlay. And it will give me a ratio. And I'll tell you in a moment that why this ratio is important. So suppose there are two projects, P1, and let's say the NPV is, for example, let's say $5,000. And let's say the investment involved is, let's say, $5 million. Now all of a sudden, and let's say if there is another project for which the NPV is same $5,000, but the investment here is only, let's say, 500,000. So in the first project, the investment is actually 10 times more. And in the second project, the investment is of course less, but the NPV on both of them are exactly the same. So if we consider only the NPV, of course, both these projects are equally attractive. But it doesn't tell us the whole story, because the investment in the first project is 10 times more. It's $5 million compared to 500,000 investment. So in order to get a better picture, what we can do, we can actually calculate a ratio of the present value of all cash inflows with the initial cash outlay, and it gives us a very good idea. It can also be expressed as 1 plus NPV divided by ICO, and the way we do it, because NPV, if we remember from our previous slide, was, let's say, if this whole expression, if I express it with summation sign, minus NPV was minus ICO. In this case, PI is equal to the whole summation sign and then divided by the ICO. What we can do, we can actually substitute this value. So from here, PI equal to, and if I transfer it here, so it will be NPV plus ICO divided by ICO. So ICO cancels out with ICO, so it's 1 plus and then NPV divided by ICO. So it's plain and simple. It's a different way of expressing the profitability index. Now, the profitability index for basket runners is 0.9643. If you remember from my previous slide, we already got that number. So if I take you to the previous slide here, so we already calculated the present value of all cash inflows, and then the initial cash outlay or the cash investment is $40,000. So once I calculate the ratio, it's 0.9643. Now, should we accept the project or should we reject it? We cannot accept the project, it will be rejected because the profitability index is less than 1. So the acceptance criteria, so we accept if PI is greater than or equal to 1. And if it's less than 1, we reject that project. Strength and weaknesses, again, just like in PV. So the method of calculating PI and NPV are very, very close. In NPV, we subtract the initial cash outlay, and in profitability index, we calculate a ratio and instead divide it with the initial cash outlay. It allows for comparison of different scale projects, and the reason is because it's an index, it's a ratio, and ratio can be easily compared. So that's one of the strengths for PI. Weaknesses, so all the weaknesses which applies to NPV, PI has the same weaknesses. The other weakness is actually it provides a relative profitability. So in one situation, actually it was a strength, but let's say if we are considering different projects, for one project, let's say if the total investment is only $5,000 and PI is listed, let's say 2.1, and then there is another project with $5 million and PI is, let's say, 1.5. Of course, based on PI, the first project is more lucrative. And so let's say if we are using PI only PI for project evaluation or project rankings, we may actually, let's say, reject this project. So suppose, let's say, if the company wants to undertake only, let's say, 7 projects in a year, and this project number 2 does not fall in the top 7, they may end up actually rejecting this project. So it's one of the weaknesses. It takes only the relative profitability, and it does not take into account like the overall quantum of profitability. Of course, in project number 2, since the investment is $5 million, a PI of 1.5 would be very, very strong, which means almost $2.5 million worth of profit. So that's why it's the same potential ranking problem. So in this slide, I will summarize all the 4 techniques for you for project evaluation. We use basket wonders example in this one. So based on payback period, we accepted the project. And the reason we accepted the project, because the project payback period was 3.5 and the acceptance criteria was the project payback period was 3.3 and the acceptance criteria or the cutoff was 3.5. So since the payback period was less than the acceptance criteria, that's why we accepted the project. But based on IRR, NPV, and profitability index, we had to reject that project. And the reason all these 3 methods resulted in a similar conclusion or a similar decision, because these ones takes into account the time value of money. So it's a discount cash flow technique. So all these 3 are actually discounted cash flow techniques. So it takes into account the time value of money. The other difference is that IRR, NPV, and profitability index takes into account all the cash flows. So payback period does not take into account all cash flows. That was one of the weaknesses. IRR, NPV, and PI, on the other hand, it takes into account all the cash flows of the project life cycle. I'll give you a very quick Excel example again, and it's easy to calculate NPV. So same example, I have some cash flows here. Actually, let me do it for you again. So the required rate of return is 14%. So my first task is actually to calculate the present values of all cash flows. So this number divided by 1 plus interest rate, sorry, discount rate, and then divided by year. What we can do, actually, we have to lock this cell for interest rate because you will be using the same discount rate for all discounting, for calculating all present values. So press F4 and that cell is locked. And once I double click here, all the values are actually calculated. And then I can do, actually I can auto sum here. I can confirm the range and then press enter. So the net present value of this project is, let me actually make it a little bit more presentable. So if I press $, it will be automatically converted into currency signs with 2 decimal point for cents. And let me convert this one as well. Okay, so the net present value of this project, in which the initial investment was $404,000 and 424. Let me give you actually another example as well. So same example that we used in my last lecture. So suppose the discount rate is 14%. So what we can do, let me do it again for you, and let me enlarge it a little bit. So if you remember from that example, a management is considering a certain project in which the initial cash outlay was minus $700,000, and then in the first year they were also required to make a $1 million investment, and then in the second year they were hoping to get $250,000, and then of course the third, fourth, and fifth year up to 10 years. So the lifetime of this project is actually 10 years. And if I convert all the cash flows here again to $, and now what we can do, we can calculate the cash flows, the discounted cash flows, divided by 1 plus the discount rate, and press F4 to log that cell, and then of course raise to the power n, and double click here, and what I can do auto sum here, press enter. So this is my NPV. And we can actually make it to 2 decimal points. So the NPV of this project is actually minus $54,000. So based on the criteria, we have to reject this project because it results into negative present NPV. So anything in negative for NPVs, we reject those projects. So coming back to my presentation, I covered all 4 techniques in my lectures. All of them are pretty simple. All of them have certain strengths and certain weaknesses. Of course, once you start working in a certain company or in a certain firm, you will have probably sophisticated tools to calculate NPVs and other project evaluation methods. But the point is, rather than using the tools, you have to understand how every technique is working, and you have to understand the math and the logic behind every technique. So I'll encourage you to do some exercises at the end of the chapter, and if you are facing any problem, please contact me through my email or drop me maybe your question through WhatsApp group. We are using the same book. It's Fundamentals of Financial Management, and we are actually in chapter number 13 right now. Uh, Feedback is super important. I'll share this link with you, and please share your feedback with me, and I'll be happy to uh, fine-tune my lectures according to your feedback. I thank you very much for your attention, and as I said, if you have any questions, you can reach me through my email or maybe drop your question at the WhatsApp group. I'll see you in my next lecture. Have a wonderful day. Thank you.